Thank you very much. So I'm already ready. So my name is Torsten. I'm the regional sales manager for DACH region and Eastern European region at Scale Computing. I'm at Scale for more than 1.5 years now, and I'm the single point of contact for all our partners and customers. So whenever you have a question, just reach out to me. And now I will just introduce Scale itself, just in a more or less short presentation, and we hand over later to William, who will do a live demo, and he will introduce himself when he's in the role, let's say. Thank you very much. So Scale, we are a US-based company in Indianapolis. Our European headquarters based in the Netherlands. And we are doing a hyper-converged solution and targeting small and mid-market IT customers and edge computing customers and distributed enterprise customers. So what we do, so that's, let's say, part of our DNA. So we want to do things very easy and reducing the complexity you basically know from traditional IT infrastructure solutions. That we are doing with our hyper-converged solution, which is based, or we're working together with a couple of technology partners. So we do have Lenovo and Intel as hardware partner, working together with Google from a cloud perspective when talking about public cloud scenarios. We have also some software partners like Acronis, Parallels, and Leostream. We give the support, so you need only to call Scale support when you're using one of our technology partner solutions. We do have a support, which is also a quite simple model, just 24/7, 365. That's the only thing we do have, and we, from my point of view, have a quite nice support because we have a net promoter score, which is 91, which is, from my point of view, the highest in the HCI industry. We do have a couple of customers all over the world. These are just a few customers. A few customers in EMEA region, in Austria, like Zillertaler Gletscherbahnen, or in Benelux, Ahold Delhaize, which they're running 800 stores with Scale Computing. Basically, I would like to say our customers are more than happy about Scale because they save pretty much on time. They have a much better availability. They have much less problems, and they save a lot of money because they don't need to spend that much money into infrastructure solutions, which they would do with other solutions. Because IT infrastructure is basically very complex, because it's very, very easy to make complex and difficult software, but it's very difficult to make easy and intuitive software. From our point of view, we did that. We will see that later on when William shows us how easy Scale is. And everybody know, I think, that complexity is always expensive, requires many people and training. And if you compare IT infrastructure with driving a car, meaning you will crash sooner or later with driving as a mid-market customer or a normal driver driving a Formula One car. Difficulty. So just talking about, for example, VMware. VMware has 118 training courses on their academy. From my point of view, couldn't be easy. Anyway, many customers, by the way, moved away from VMware, for example, Apple or eBay or PayPal, a couple of these type of customers. So they're using now KVM-based solutions like Scale Computing. As I said, crash or drive, things like driving IT infrastructure, you can easily compare with driving a Formula One car. So you need your engine tuning team, you need the tire management team, you need the pit stop team, and many, many more. They need to cooperate and communicate intensively to each other. They are very capital intensive, so they're very expensive. You need to pay everybody here. Can easily compare that with IT infrastructure. meaning you have the networking guys, the security guys, the storage guys. However, they also need to communicate all the time to know what they're doing, which is not typical for a mid-market IT company, because what will happen then with these kind of mid-market customers with 1 or 2 IT people drive the Formula One car? Yeah, it will crash. And what do they really want is just sit in the car and driving. That's easy. So that's the way how easy IT infrastructure should be as well. And we can do that easily because we're doing real hyperconvergence, which means we're combining server, storage, and virtualization in one solution, which is called Scale Hc3. You know this, maybe you have that in your data center, a couple of servers, storage network, storage. Just thinking about doing an update from your hypervisor, you need to read a couple of HCL lists just to be sure which firmware fits to which disk level, whatever thing. So that's very complicated, and hyperconvergent basically wants to do things easier, and that is working, but it's working on different ways. Most of our competition products are using the so-called VSA, Virtual Storage Appliance model, which means AVM is running on top of the hypervisor, getting all the disks which is included in the system, showing itself and the other machines through the network, meaning all the traffic go through all the steps and the stacks and a couple of times. That's basically still working, but you need pretty much resources to get these up and running. For example, Nutanix is doing the best here, and they just need at least 24 gig just to get the Nutanix solution itself up and running. If you're using some more things, you need much more memory. You need a couple of cores, at least 8, most of the time 12. In other words, when you change in a Word document a comma to a semicolon, you need to go through 36 steps. When you compare it to Scale, there are just 12 steps, meaning 1/3, meaning the latency is much better. We only need a maximum 4 gig of RAM per node. So in other words, you get more for the same. So the density of your virtual machines in a Scale solution is much higher, or you can use less hardware. And for that, we are able, because we do have a different architecture, we are able to create the smallest HCI cluster in the world. As I said, we have a product which is based on simplicity, which means we do have just a browser to manage all your Scale solution. Our appliances are pre-configured. Deployment is done quite quickly. Basically, you need more time to rack and stack the systems than the installation itself. We do have self-healing technologies, high availability, deduplication, snapshots, and whatever kind of things. We will hear about that more in detail just in a few seconds when William is taking over the demonstration. We for sure can scale the systems, can use single nodes, can mix and match. That means if you start with a Scale cluster, you need to add a node that can have a different type of CPU, different type of memory, different amount of storage, and that working in the same cluster. So that's not like if you need to change something, you doesn't need to throw away your cluster and buy a completely new one. Never you need to do that. Because we do have a complete stack. There are no software licensing. Everything is included in the solution, and we have a quite nice price. We hear about that just later on. Deployment scenarios of Scale computing. So basically, you start with a central data center cluster. If you like, you can replicate to another DR cluster, to a backup node, into the cloud, or your location can replicate to your data center. Everything is possible. Replication is always bidirectional and vice versa possible. This is our portfolio. starting with the He150, which is really the smallest HCI cluster in the world, which is an NVMe-based system with up to 4 terabyte disk. So that will be available up to next week. We have the He500, He1200, and Hc5000 series, which could be an all spinning, all flash, or hybrid system. You can put 1 or 2 sockets into that, different amount and or different size of disks and or SSDs. And the Hc3000 series, it's an all NVMe system only, where you can get up to 76.8 terabyte per node NVMe storage for, at the end, nice price. So just let me know if you are interested in these kind of systems. If you need some GPUs, maybe for VDI stuff or whatever, you can put GPUs into the Hc1200 series or in the Hc5000 series. Just one additional slide, but I will go quickly about that. We have a promotion together with Hermitage and Scale Computing for these He150 and He550. So for a special pricing, which is a promo pricing about 8,500 euros for the He150 Edge or the He150 HCI 10,900 instead of 14,116. So please talk to the colleagues of Hermitage if you're more interested in this configuration. That's just the last slide from my side. I will say thank you very much. And now we hand over to the live demo of William.
Thank you, Torsten. So hi, my name is William van Kolenberg. I'm a sales engineer at Scale Computing. And in a previous lifetime, I've worked for VMware, I've worked for Citrix, I've worked for Dell. So I've been around in this technology, and I've prepared a small demo for this webinar. So what we see over here is a Scale cluster GUI. This cluster consists of 3 nodes, which are running in my local data center over here. And because I thought it would be a nice extra for this demonstration, I've also prepared a replication to our cloud, Unity Cloud. So in the top hand, left-hand corner over here, a very nice logo, obviously, and next to it, the name of the cluster. Below the name of the cluster, we see the version number. And the version number isn't the most important thing here. What is actually important is how we deal with these updates. So when a new update is available, and this is approximately every quarter, give or take a month or something like that, when a new update is there, a yellow text will appear over here saying an update is available. When you click on that, or you click on the version number, you will go to the control center and will see the update page. In this update page, you will have a description of what's in the update and a big black button over here that says apply update. When you click that button, everything else is fully automated. In other words, the first node will be evacuated, as we call it. That means all these VMs that are running over here are live migrated to the other 2 nodes. Once it's empty, the node will be checked for a good health. When that is okay, it will be upgraded and if needed, rebooted. And at the end, it will be taken back into the cluster and all the VMs will be put back. Then we continue with the second, the third, the fifth, whatever. This means you can perform this update without downtime. Now, we at Scale, we are very explicit in the sense that we are selling appliances only. This means that we have pre-configured hardware with the software already on it. That also means that we know what the hardware is below these systems. So a Scale update does not only include the required software updates, but it can also include required hardware updates. And this, again, comes with 2 different benefits. The first one being you don't have to read HCLs, like Torsten said in his presentation. You don't need to go and figure out which firmware is compatible with which driver is compatible with which operating system patch level or whatever. No, we take care of that. The other thing is you only have one update moment. So it's not that you first have to reboot your systems for firmware upgrades and then have to reboot them for driver updates and stuff like that. No, everything in that update is being handled as part of a single update process. So you don't need to worry about it. Then when we go to the middle of the screen, we see the telemetry of my cluster. And obviously this is the joint telemetry of my cluster. And you can see that I'm using about 16% of all my CPU capacity. I'm using about 45% of my RAM, etc. At the disk dial, I can actually click on it and I will get some additional information. So over here, you can see that I'm using about 11.4% or 3.37 terabytes for my VMs, and then I'm using 3.32 terabytes for my snapshots. In the efficiency section, you can see that I'm actually deduplicating about 7.79 terabytes, so almost 8 terabytes saved in deduplication. Now, my environment mainly runs a VDI workload, and VDI obviously can be quite highly deduplicated. In a regular server environment, you would be seeing between 5 and 15% approximately, but obviously that comes without guarantee. When I look at provisioning, you can see that I've provisioned about 70% of my cluster, but I'm saving 49% by using thin provisioning. On the right-hand side over here, you see the notification center. And if I click on this, you can see that I'm going to the conditions page in my control center and that there's nothing wrong. The entire top bar of this GUI is called the heads-up display. And this heads-up display, I do not only have this available for my local system, but I also have it available for my remote clusters. So as said, I prepared this demo to also include our Cloud Unity portfolio. Shouldn't have clicked that. Our Cloud Unity portfolio. And over here, I can also see all the telemetry of my Cloud Unity environment. When we go one level down, you can see over here, these 3 blocks over here are the IP addresses of the nodes. So I have 3 nodes, which you can recognize by these IP addresses. And you can see that I'm connected to the first node in this cluster. This is not necessary because every node in a skill cluster is fully capable of doing all the management of a cluster. We do not have a single point of failure for our management. So for example, if you're using Hyper-V, you would have SCCM Virtual Machine Manager. If you're using VMware, you would have a vCenter server. We don't have such an entity. Every node is a full management node. So without any problems, I can connect over here to the second node. And as you can see, I can perform the same level of management. On the right-hand side of every node, you see the amount of RAM that's free. That's 126 gigabyte, or 128 gigabyte. Actually, that it's noted in gigabyte only proves that the product was written by nerds. And you can see that I have about 63 gigs of RAM free on my first node, 58 on my second node, and 51 on my third node. As Torsten said, we do full mix and match. This means that we can mix and match storage technologies that are below the solution, which you will see later on, but we can also mix and match the amount of RAM. If after running a cluster for a year, you find out that you actually have more RAM heavy workloads and you require more RAM, you can just add another node with more RAM or with less RAM, with bigger processors or with smaller processors, with faster processors or with slower processors, and with different generations of processors. Everything can be mixed and matched. Now in the storage part of this, there are some rules to that. You cannot grow more than the total that you already have if you just add a single node. But the general consensus is you can grow in every way that you want. Now, going a bit lower, these white lines over here are a representation of the RAM that's being used by the different VMs. In the same overview, I also have a disk overview, and here you can see that I have a hybrid system. Our hybrid systems are systems with a spinning disk and SSD in there. And in terms of the mix and match, they are the most flexible systems, as a hybrid system can be expanded with additional disk-only systems. It can be expanded with additional hybrid systems, and it can be expanded with additional SSD-only systems. So depending on your needs, when you grow, you can actually grow. Last but not least, we also have the opportunity for, when you are doing such an expansion, to do a storage-only expansion. So let's say that all that's happening is you are running out of disk space, but you have CPU and RAM more than enough. We can actually also add a node that only adds to the storage, and in such a way saves you Microsoft licensing for CPU licenses where a hypervisor runs. All the disks in a scale cluster are part of one large storage pool. So we do not do separate storage management, and you do not need to plan ahead to see where you need more performance and where you need less performance. No, we do this in a dynamic way, and we can manage this per virtual disk. So in my demo environment over here, when I go to my domain controller and I go to the devices, you can see that over here I have two virtual hard drives, a C and an F drive. When I click, excuse me, when I click on more over here, on the top of the screen, you see the general configuration. For instance, I can grow this disk over here. And on the bottom side, you see the hypercore auto tiering priority. With this slider, we set how much of the spinning disk and how much of the SSD is being used. So when I set this to 0, all data will be essentially written to the spinning disks. When I set this between 1 and 10, all the data will be written to SSD, and depending on the age of the data and depending on data from other virtual disks with a higher priority, that data will later be offloaded to spinning disk, thus giving you the right performance of the SSDs. And as long as that data is current, the read performance of SSDs, and when that data becomes older, you will get the read performance of the spinning disks. When you change data, that data is moved back to the SSDs again. When I set this to 11, all data will obviously be written to SSD, but the system will try to keep that data on SSD forever. Hear me say try, because if the SSDs fill up, if they become too full, data will still be offloaded to make sure that the system keeps working. That story actually takes us to the virtual machines. So a new virtual machine is extremely simple. It's actually as simple as typing a new text message on your handy. So you click the plus button, we give this a name, we can give it a description. I usually don't, but you can do that. Tags in this example are actually quite important, because the first tag will also become the grouping of that VM. So over here, you can see that I have a group which is called infra services. In such a same fashion, I'm building a group that's called demo here over here. But I can, for instance, also say this server is part of the app1 group. So let's say app1 is a web server that has a backend server, a front-end server, and a database server, and possibly even a load balancer in front of it. So I have these 4 servers that together make the web application. Now, if I want to update such a web application, but I want to make a snapshot just to be sure that if it doesn't work, I can roll back, I actually want that snapshot of those 4 machines to be at exactly the same time. So all of the tags, including the grouping tag, can be used with the filter here on the right side, and that filter can perform actions on all filtered VMs. So making a snapshot of the app1 can be done by filtering on app1 and then performing a snapshot. Or on the other hand, also all of the tags can also be used with our API, which I will show later on. In the operating system section, I can choose for Windows or something good. Yes, I have an opinion. In the driver section, I can choose performance or compatible. Performance are the Red Hat KMU drivers. Compatible are the standard IDE and Intel E1000 drivers. In the CPU section, I can choose how many CPUs I want for my VM. And in my case, this is limited to 24 because I have 3 nodes, with each node having 2 6-core CPUs. With hyper-threading makes that 12 virtual cores per CPU, so 24 virtual CPUs per system. In the memory section, I can determine how much RAM I'm going to assign. In the drive section, I can determine how big my hard drive is going to be, or I can even add an additional hard drive or more additional hard drives here. And I can indicate a boot image. So in my case, I'm going to choose Server 2019. When I click create over here, you will see that the demo group is automatically being created and the virtual machine is actually being made between 5 and 15 seconds. Now, this virtual machine still needs to be installed. So although I very quickly have the virtual machine ready, I would still need to take time to install. Another thing that we can very easily do is we can define templates, and I can simply just create a template over here, put it in the demo group like this, and create that clone. And you will see that in that same 5 to 15 seconds, I will have a fully set up Server 2019 at the ready. The last way of getting systems into or getting virtual machines into a scale solution is by using the import button. Now, this import button says Hc3 format VMs only. I'm going to tell you the biggest public secret that we have within Scale. It also accepts VMware VMs and Hyper-V VMs. And the conversion of those VMs is completely automated within the cluster. The last way to get a virtual machine into this system, so there is actually another import way, is we also sell migration tools. So this is called Hc3 Move, and Hc3 Move essentially is a P2V or V2V solution with which you can create a synchronization between a running VM on VMware on Hyper-V or a running physical machine. You can create a synchronization to our cluster, and once that synchronization is done, you can perform a failover to the cluster. And by doing so, reducing the downtime for a migration a lot. So what is in a VM? I'm pretty sure that it comes at no surprise that we have a power button for the VMs. But when a VM is already running, that power button also gives you the possibility for a graceful reboot, a graceful shutdown, or a hard power off. Then we have the console. So this button over here is the console button. And the console, like the rest of the GUI, is actually HTML5 without the need of any plugins in the browser. I can work with this virtual machine and do management. Then the devices tab. The devices tab is actually more interesting in the virtual machine that we just created, because over here you can see that not only do I have the Windows Server 2019 disk over here, which I asked for, remember, but also the Scale guest tools are automatically mounted because I said it was going to be a Windows virtual machine. These Scale guest tools contain all the drivers for the virtual machines, but they also include the VSS driver. So that enables our snapshotting mechanism to inform the operating system that we're going to take a snapshot so that the operating system can perform a so-called QoS, which means that all the data that still needs to be processed is in the CPU or in memory will be committed to disk so that you get an application consistent snapshot. Below that, we see the 2 disks, and we've already seen the disk configuration. But for instance, I can make the disk bigger here. I can also do this when the VM is already running. When the VM is not running, I can actually also change the technology. So let's say that I made a mistake in creating this VM and it needs to be a more traditional system. I can choose IDE. The last time I used IDE in a Scale cluster was when I was installing OS2 Warp. So might not be that current. Then below we have the networking configuration, and networking is something that we do slightly different than our competitors. So At most of our competitors, you first need to create a virtual network, and then you can attach machines to that virtual network. I said we do it different, but we actually do it the same, but we don't leave that configuration over to our users because it's always the same action and it always works the same. We have said, no, we're going to manage this on a network device basis, because with the network device, you must indicate where it needs to connect. And if that is something that is new, we will automatically create the infrastructure that is required for that. So in my environment, a virtual machine needs to be in VLAN 102 to have internet and to be allowed into the server network. So when I do this, the rest of the configuration is automatic, and this virtual network card is being attached to a virtual switch which has VLAN 102 defined. Now, if I create a new network card, and by the way, I can also choose other chipsets over here, I can put this in a different VLAN, and it will automatically also accept that configuration. And if this is a VLAN that I have, oh, that's impossible. If that is a VLAN that I've never used before, that VLAN configuration will be automatically done in the required vSwitches. Last but not least, I have the buttons for the new disk and the button for the new network card, but I can also choose to change the boot order over here. And as per example, I could make this network card bootable to do the deployment through Pixie, for instance. The last menu item over here is the Snapshotting Engine, which is actually more interesting to see in a running VM. Going back to my domain controller over here, when I click on the Snapshot Engine over here, you can see that I have 40 active snapshots over here. Now, I don't know how many of you have tried this with VMware or Hyper-V, but with Hyper-V, you run the risk that every snapshot becomes 4 or 5 times bigger than the original VM. And with two or three active snapshots for over 2 or 3 weeks, everything will become incredibly slow. We don't have that problem because of the way that our file system is built. Because we have a block-based distributed file system, we don't have to be perfectly honest, idiotic overhead that those solutions have. And we support up to 5,000 snapshots per virtual machine. This means that I can do entirely different things with my snapshot without the negative performance impact that you have with those other technologies. I could even set up a backup schedule. So what I have over here is I have this system configured to use the gold schedule. Now, when I go to my control center and then to my schedules, you can see I have that gold schedule over here. And when I click edit, you can see that I do a snapshot every hour, which I locally keep for 6 hours, and remote I keep for a day. Then I make a snapshot every day to overlap with that one, which I locally keep for 3 days, and remote I keep for 2 weeks. And then I do a weekly snapshot, which I locally keep for a month, and remote keep for half a year. And there is nobody stopping me from saying, you know what, let's make this 7 years. It will still function. I'm not going to do it because of storage requirements. So going back here, you can see I have 40 snapshots, and my oldest snapshot here is from the 5th of June. This is American dating, so it's month first and then the day. So this is the 5th of June, which is when I received this cluster. And I still have this here, and it's still not impacting my environment. Now, you said, William, you were talking about remote. That is correct. I was talking about remote because you can see over here that I also have a Cloud Unity environment configured as a replica partner. And when I click on this, which I already did, you can see, I'll close this one. You can see that I have that same domain controller over here. But because my retention remote is longer than my local retention, you can see that over here I have 72 snapshots. But over here, I still also have that 5th of June snapshot without any problems. I can still work with the system. So how does this help me in backing up? Because I hear a lot of people thinking on the other side of my screen, hey, William, a snapshot is never a backup, which essentially is true. because if you lose the original virtual machine, the snapshot data is worthless. The same goes for replication. Replication is not a backup, because if I destroy data in a VM, I will also destroy that in the replica. Otherwise, it wouldn't have been a replica. What we do is snapshot-based replication. As you can see, the snapshots are the things that we transport to the other side. So in my case, in my local environment and in my cloud environment, I have both, on both sides, the original VM, and on both sides, I have all the snapshots. So I can do a full VM recovery, and I can do a file level recovery from a VM. Did you just say file level recovery, William? Yes, I did. So over here, I have my domain controller over here, and on my domain controller, I have a drive with shares. Oh, thank you. I have a drive with shares. So my F drive contains the shares, and what you see over here is that I have a lot of English, Dutch, and German very important data. Unfortunately, I had a couple of beers last night and I wasn't realizing what I was doing, and I deleted everything. Job lost. No, are you saying, William, you can still go back to a snapshot, which is correct. However, I can go back to a snapshot until I make new data. Because a snapshot is a a point in time copy, when you go back to a snapshot, everything that came after that point in time is no longer there. So if I were to go back to one of my snapshots right now, I would destroy the until I make new data file, which obviously we don't like. So what we can do over here is I can do this from my remote snapshots, and I can do this from my local snapshots. I'm going to do it local now because that's a little bit quicker. I go to my snapshots, and as you can see, at 1 p.m., I had a regular snapshot. As you can see, and you've probably also seen that in the lower right-hand corner over here, a couple of tasks have been running in the background, which is my Acronis backup, which is currently running. But at 1 p.m., I had my regular snapshot. I can go over there. I know that the data was on my F drive, so I go to the F drive over here, and I select a recovery virtual machine. Now, I could use one of my terminal servers, or I could use one of my VDI workstations. For this demo, I'm going to use the same machine, but I think in general, you would have a separate recovery VM because you don't like to mess around in the disk manager of a production VM. I press the clone button over here, which makes a clone of the block device and mounts it to the virtual machine. And as you can see, this is actually immediately done because this is a deduplicated linked clone. So what I can do right now is I can go to this virtual machine over here. I go to the disk manager. And in the disk manager, I bring this new disk that just appeared online. This means it gets a drive letter. So when I go back to my browser over here, you can see that I now have the G drive where I have my shares, where I can copy this data, go back to F and to shares and paste it. Now, in the way that I just did it, you lose all the rights. So the rights assignments are now the same as inherited by folders. If you do this, for instance, with Robocopy or a program like that, all the rights are also maintained. So you can choose how to do this, but there's many ways. And anyway, what I wanted to make clear with this part of the demo is that with just a cluster and a replica system, and this can be a cloud replica system, but this can also be another local replication system or maybe in another office, I can perform file level recoveries, which is basically the first big step in backup. The only thing that we do not support with this mechanism is making or doing application-based restore. So let's say that you are still running your own Exchange environment, or you have a lot of SQL databases, and you require the possibility to do a single email restore or a single SQL row restore. For that purpose, we have a joint venture with Acronis. So Acronis is capable of doing agentless backups of the of a skill system. So I can go to my Acronis environment. Log in here, and as per example, I can show you the skill computing Hc3 cluster, which is registered here, which has more or less VMs backed up. And this gives me the possibility of doing application level resource like Active Directory objects, Microsoft SQL objects, Exchange objects, Oracle objects, and so on and so on. Last but not least, almost out of time here. I have 15 more minutes, so let's go over the control center. The log should actually do this so that it is no longer there. That's one of the reasons that you want to do this on a recovery VM and not on the production VM. When I go over here, you see that every action is named. So you can see that I was the one who deleted that block device. So if that was not supposed to happen, you can ask me to please vacate the premises. Conditions, we've seen this connected to my notification center up here. If there is anything, a detailed description will be over here. In the control page, I can shut down the cluster. In the media page, I can upload my own ISOs. In the remote cluster section, I can see all of my remote clusters. And this is there for all the remote clusters, whether they are or are not a replica target. In the remote support section, I can open a support tunnel to the skill support department. So if you have a skill cluster and you have a problem with it, by opening up a connection to our support department can see into the cluster and help you solve the problem. This, by the way, is an outbound connection, so you don't need to configure any inbound firewall rules to your cluster. Schedules, we've seen those. Settings is where all the generic settings are, but this is also where we configure our REST API access. And it is where we have our REST API browser. So over here, I have all the different REST API calls that I can make. And the nice thing about this REST API browser is it also enables you to try all these things. So let's say that we want to have all the statistic information about our virtual machines, which in our terminology is the vir domain. So I can say, oh, there we go, vir domain. The get command is read all the data. So we have get for reading, post for changing, patch for changing, and delete for, or actually post for creating, patch for changing, and delete for deletion. And here I can say get a list of VMs with their information. Or actually, I want to have. I am sorry. I want to get the statistics. Obviously, I want to see what's going on. So over here, I can say try it out. I say execute. I have to explain that I am really me. Oh. There we go. And you can see that I have a virtual machine over here, which has this UUID. By the way, the UUIDs can be read back in the one that I just selected earlier. And you can see that, for instance, this system has 352 milliwrites a second, that the main write latency is 420 seconds, 426 microseconds, so that's 0.4 milliseconds. You can see that my CPU is being used for 3 point and a little bit percent, that I'm currently not doing any networking over there. So you can basically get all of that nice information out of that system to, for instance, read back into your Splunk system or any other monitoring system. One of the very nice open source ones, for example, is Postman, which is perfectly capable of reading this JSON formatted information. Then over here we have the SSL certificates that you can upload. You can upload them over here, but you will not see them back because obviously your SSL certificate information is very sensitive information. As you can see, I currently have not done this because I actually have my certificate on the outside, on the internet side. Update page we've discussed. If there's an update available over here, you can see what's in the update. User management is where I can create multiple users. And for instance, I really like Torsten, but I don't want him to change any cluster settings, so I took that right away from him. Support has a list of the support documentation, and when I click exit, that is actually the end of this demonstration. So I'm quickly going to take a look at the